Today we're going to look at exponential functions like y equals 2 to the x. This is exponential growth and exponential decay, and I'll try to point out which one is growth, which one's decay, but we will get to that eventually. So with your graphing calculator, number 1, we're going to enter y equals 2 to the x into our y1. So in the blue y1, y equals 2 raised to the x. To raise something to the x, you have to use your exponent button, which is directly above your division key. And then remember, x is the button next to your green alpha button. And once you have that entered, hit graph, and let's see what it looks like. This is an exponential growth graph. 2 to the x means that you're basically repeatedly multiplying by 2. So this thing doubles and then doubles and then doubles and then doubles, and that makes it exponentially bigger, an exponential growth curve. A couple things that you might notice, take a look at the left side of this graph. What do you notice about this left side? It gets really flat, and it doesn't cross the x-axis. That is called an asymptote, which I don't think we've talked about before. The word asymptote is a very awkward math word that has not nearly enough vowels for the number of consonants in the word. And the correct way to say this word is seriously to say every single letter in this word. Asymptote. But when you say asymptote, if you're saying it quicker, it just sounds like asymptote. It sounds like you're not even saying the P and the T, but technically it is in there. So this graph has an asymptote at y equals 0. Remember, y equals hoi is a horizontal line. So there's a horizontal line at y equals 0 that this graph is not going to cross. To see a table, push second and then the graph button, and that will take us to the table. And we can record some of these values into our table. And notice the x values are given to us. You can use the up and down arrows to get to the different x values if you need to. So negative 2.25, negative 1.5, 0, 1, 1, 2, 2, 4. Plot those points and get a picture of the graph on your paper. When you graph this, on the left side, you need to make sure that you do not cross the x-axis. There is an asymptote, and the equation for that asymptote is y equals 0. It is a horizontal asymptote, so hoi, y equals, and it's right at the x-axis, so that has a y value of 0. Now take a look at number 2. What do you think the minus 3 in the exponent is going to do to this graph? Any ideas? Maybe. Okay, get in your head what you think it's going to do, and you can base this off of things we've done in the past with graphing if you want to, and then type this in. You can leave 2 to the x in your y1, go down to the red y2, and enter 2 raised to the x minus 3. And then graph it and see what happens with this graph. Okay, this graph is shifted to the right, and if you look at one of these points, it's shifted right 3 units. So this minus 3 shifted the graph right 3 units. As we fill in this table, notice that they're giving us 2 of the y values to look at. So if we go to the table, second graph to go to the table looks kind of weird when you have multiple things in here. So the blue, that's from number 1. The red is our y values from number 2. So they want us to look for the y value of 1 and the y value of 2 and the corresponding x values. So when y equals 1, x is going to be 3. When y equals 2, x is 4, and then they want us to fill in around that. Just a warning, my OneNote has been flickering and being kind of ridiculous lately. So if it flickers white, the values in my table might just disappear. Sorry about that. What do you think is going to happen in number 3 with the plus 2? Left 2. So adding and subtracting in the exponent with the x, anything that happens with the x, either inside the parentheses or underneath the radical or up in the exponent, that's going to be side-to-side movement. So if we go down and answer number 4, what does the minus 3 do? It moves the graph right 3. The plus 2 will move the graph left 2. So what do you think minus 12 in the exponent would do? Any guesses? Right, 12. So what effect does the number added and subtracted to the power up in the exponent? What effect does that have? It moves the graph left or right. And you may want to include with left that plus is going to move it to the left and minus is going to move it to the right. So notice that it's backwards, just like side-to-side movement has been for every single type of function that we have graphed. E is talking about the asymptote. So there is an asymptote. That's a Y. An asymptote is a line that the graph will approach but not cross. So if on this table, if I continue going into crazy negative values, if I continue going to the left on this graph, notice that the values are getting closer and closer to 0, but they're never exactly 0, and they're never negative. So they're getting closer and closer and closer to 0. Like 9.5 e negative 7, that's 9.5 times 10 to the negative 7th. That's 0.00000009 something something. So as we get into times 10 to the negative 10th, you're talking about 0.0000000000 something. So it's really, really close to 0, but it's not ever exactly 0, and it never crosses that line. Remember that domain is the x values and range is the y values. The domain for all of these is going to be all real numbers. The graph extends forever to the left, and that the y value or the x values are going to keep increasing to the right, so all of the x values are included. The domain is all real numbers. Every single graph that you're going to see today has a domain of all real numbers. The range is tied to the asymptote. If we look at the graph of these functions, the range, all of the y values are going to be bigger than 0, so the range is y is greater than 0. In your graphing calculator, clear out these two equations. Now we're going to put in 1/2 to the x, and let's go ahead and put number 6 in the red one, 1/2 x plus 1. For 1/2, I would suggest you do parentheses, 1 divided by 2, close your parentheses, raised to the x. For number 6, 1/2 in parentheses, raised to the x. Notice this time the plus 1 is not in the exponent. Your cursor is going to be stuck in the exponent until you tell that cursor to get out of the exponent. So you need to push the right arrow to get down out of the exponent before you add 1. What do you think that plus 1 is going to do? We already did side to side, so what do you suppose we're going to do now? Up or down? So what do you think plus 1 is going to do? Move it up 1. Let's see if we're right. Push graph. Notice the blue graph, the numbers, the y values are decreasing. This is exponential decay. but we still have an asymptote at 0. In number 6, that +1 moved the graph up 1, which also moved the asymptote up 1. So as you start getting familiar with these, some people say, oh, hey, look, this graph is going to move up 1. That means the asymptote moves up 1. So I'm going to draw in a dashed line up 1 so I make sure that I don't cross that line when I graph it. If you're graphing these and you cross the asymptote, it will be counted wrong. You cannot cross that asymptote. So this time the asymptote is at y equals 1. This also affects the range of the graph, and I suppose I should use the right colors. So the range for number 5 is going to be y is greater than 0 because the asymptote is at 0. Anyone want to take a guess what the range is for number 6? Y is greater than 1. Y is always greater than the asymptote. What do you suppose is going to happen in number 7 with the -1? This would move the whole graph down 1, which would also move the asymptote down 1, and that would make the range of the graph y is greater than -1. So take a moment and answer the questions in number 8, and then we'll move on to the last page. If you're watching the video, you might want to pause right now so you can write this stuff down, because I'm not going to stay on this screen for very long. For number 7, I want you to clear out everything in your y equals. And then notice, why am I not able to do this? Okay, there we go. There's colors associated, so put this first equation in 7a in the blue, y1. Put the second equation b in the red, y2, and put the third equation c in the black, y3. And then we can look at all 3 of them in all 3 tables at the same time. So take a moment and complete this on your own. Go. You may want to pause it on this screen. I'm not going to stay here very long. Technically in C, the -2 is also a vertical stretch because we're multiplying by 2. But the important thing that they want you to notice is that negative in front flips it over the x-axis. That is also going to affect the range. So in 7a and 7b, these both have a range of y is greater than 0 because the asymptote is at 0. But think about the range for C. Are the y values larger than 0 in graph C? The y values are less than 0. So when we flip over the y or over the x-axis, we're also flipping that range from positive numbers to negative numbers, so y is less than 0. So if the graph is above the asymptote, its y is greater than the asymptote. If the graph is below the asymptote, its y is less than the asymptote. What do you suppose in 8 the negative in the exponent is going to do? What's the difference between a negative being in front and flipping over the x-axis or the negative being with the x? What do you think that's going to flip it over the y-axis? So if we happen to have a negative in the exponent, which I will not do to you very often because it's honestly kind of cruel, this will flip over the y-axis. It'll be a horizontal flip. So let's fill this in quick.